everyone. Welcome to this online lesson. I am Mr.Zack. I'll be taking you through a topic in Form 2 on turning effect of a force. The objectives of this topic is 1. To get to know what is the turning effect of a force, and in short, what is movement of a force. We'll also be looking at the factors that affect movements of a force, and finally, we look at calculations that go hand in hand on calculating the movement of a force. So welcome to the lesson. In Form 1, we looked at the topic force in general, and we found that force is a push or a pull. We were also able to see various ways in which a force affects a body. And generally, we found that a force affects motion of a body in various ways. Just to mention a few, a force can make a body to start moving if it was stationary, like when you kick a ball. If you push a body, it will definitely start moving if it was stationary. A force can also stop a body that was moving. Just like we apply brakes on a bicycle that is moving and you bring it to a stop. We also apply brakes on a vehicle and bring it to a stop. In that topic, we're able to see various ways in which a force affects the motion of a body. And actually, we came up with another definition of a force. And we found that a force is that which changes the nature of the motion of a body. So in this topic, we'll be looking at another effect of a force, and that is the turning effect of a force. I want you to look at what happens when you hold the doorknob and you open it. What happens to the door? It turns. Look at when you hold the tap, the water tap. When you are either opening or closing it, you have to turn it. Look at a driver steering a vehicle. When they want to make the vehicle to turn, there is that effect of a certain force applied to make it turn. So there are so many applications of the turning effect of a force. And we'll go straight to see what is this turning effect of a force. I'll show you a very simple demonstration. With me here is a half-meter rule on which I have a small string tied on it. It will hold something, and this something is a mass that I have here. If I put this mass on this half-meter rule, as you can see, when the mass is not there, it's very easy to hold this half-meter rule. But when I place the mass there, then I have to use more force to make this meter rule to still remain in position. There is a certain effect I'm feeling at my fingers. And if I were not to put enough force, then this meter rule or half meter rule is going to turn in this direction. So the force that has been brought about by this mass is bringing about this system to turn. It is making this system to tend to turn. And as you can see, if I add another mass, that effect becomes even stronger. And that effect that is being brought about by this mass, which at the end of the day will bring about the force, is a turning effect. It wants to make this system to turn. And therefore, a force makes a body to turn. The turning effect of a force. A force will always make a body to turn. This effect of a force making a body to turn, we call it moment. And therefore, the turning effect of a force is called moment of a force. The turning effect of a force is called moment of a force. From here, we'll be looking at factors that affect moments of a force. I would like you to note two things here. That when we have the half meter rule, this is the half meter rule, and this is the mass. The mass is applying the force at this point. This, we can look at it as a system. This system, where we have the meter rule and the force, it is not turning anywhere else. It is turning at a certain point. It is turning at this point that I have held the meter rule. And therefore, this turning occurs at a certain point. Therefore, we have what we call the turning point. And that turning point, we can also use another term. Either we call it the turning point or the fulcrum. And that you can also use another term like the pivot. So, moment of a force, we have the force itself that is causing the turning effect, and we have the point at which the system is turning, that is the pivot or the fulcrum or our turning point. We can just call it by any of those three names. So which are these factors that affect the turning effect of a force or the moment of a force? I would like you to look at this. I'll be holding all through this half meter rule at this point, and I'll hang one mass at that particular point. I'll maintain the distance from this point to this point, but what I'll do, I will add another mass. You can see I'm comfortably holding this half meter rule with a mass on it, one mass. It is applying a certain force. Now, let's add on it another mass. I'm telling you, if you are the one holding this, I'm sure you won't be this strong because I'm using a lot of force to maintain. What would happen now if we add the third mass? Look, it's almost impossible. What do we learn from that? As I add more mass, I'm adding more force. As we add more force, the turning effect becomes greater. So one factor that affects the turning effect of a force is the magnitude of the force. The magnitude of the force. The other factor which we'll get as we do this demonstration, in this case, I'm going to use two masses. So in this case, throughout, we are going now to put the magnitude of a force constant. We are not going to change the force that we have. And what we'll do, we'll bring these masses closer to the turning point, bit by bit. At that point, the turning effect is high. As I bring this force closer, the turning effect reduces. As we reduce this distance, the turning effect reduces. And if I bring this force so close, I'm almost feeling no effect of this half-meter turning. But when we increase the distance, the turning effect increases. Therefore, the other factor that affects movements of a force is distance from turning point to line of action of the force. Distance from the turning point to the line of action of the force. I want us to add a very unique name to this distance and call it the perpendicular distance. The perpendicular distance from the turning point to the line of action of the force. Those are the two factors that affect the movement of a force. I want to expound more on this perpendicular distance. Let's look at a situation where we have a half-meter rule like this. This is our turning point, that is the pivot, and this is the point where the force is being applied. We can draw a line along which, a straight line along which the force is acting. This line is the line of action. The perpendicular distance we are talking about is that distance from the line of action to the turning point. That is our perpendicular distance, D. We could have a different situation whereby with such a system, this being the turning point, the force acts on the system at an angle. This is the force, and this is the line of action. You notice that now we won't get our perpendicular distance along the system. We have to get a distance from the turning point to the line of action such that that distance meets the line of action at 90 degrees, perpendicular distance from the turning point to the line of action of the force. So those are the two factors that affect the movement of a force. How do we calculate for the movement of a force? We've seen that the two factors that affect the movement of a force is the force itself, the size of the force, and two, the perpendicular distance. For the two, the greater the force, the higher the turning effect. The greater the distance, the higher the turning effect. These two quantities are the ones that give us the turning effect. We can see the two are directly proportional to the turning effect. And therefore, we calculate movement as force times the perpendicular distance. Force times the perpendicular distance. That is, our moments will be the force F. Let's denote our distance with the letter D, force times the perpendicular distance. We know the units of force is newtons, and the units of distance is meters. And therefore, the SI unit of moments is Newton meters. Newton meters. That is, in symbols, capital letter N and small letter m. Newton meters. Thank you very much. In our next lesson, we'll be looking at more examples. That is, we'll be looking at a few examples on calculation of moments. Thank you.